Okay, this is period 2B. We are going over lesson 12 of code.org. We're going to be going over and learning about moving sprites. So last time, if you guys remember, we went through the first little bit of learning how to animate things. And so we reviewed the draw loop, and we learned about how it repeatedly performs the same commands over and over and over again. And we learned how to randomize, make little dots appear on the screen, and how to make stuff move around and animate it a little bit. This time, however, we're going to actually look into getting things to move in a uniform and smooth manner. So under the instructions for today, which is day 4, we can see that we can do all kinds of other fun things using the draw loop / function, and that is what we'll be investigating today. Being able to randomize things is fun, but we also want to be able to move them more uniformly and smoothly. Make sure to keep up with the lessons in code.org and get into the Zoom, which you're here, hopefully. If you're a distance learner, for some insights on how to complete the first few parts of the lessons. Remember, if you don't understand something, ask questions. Don't just sit and think that you're going to be able to understand it later and somehow all of a sudden things will click and everything will be beautiful. You have to be able to ask questions to figure it out. Right. You don't understand one thing now. Next lesson, there'll be 2 things you don't understand, and then before you know it, you won't have any idea of what's going on. And especially if you don't pay attention when the teacher's teaching because you're on your Chromebook and he asks you to put it down and listen. Yes, close the Chromebook. So, how can we control sprite movement in GameLab? In this lesson, the class learns how to control sprite movement using a construct called the counter pattern, which incrementally changes a sprite's properties. After brainstorming different ways they could animate sprites by controlling their properties, students explore the counter pattern in Code Studio, using the counter pattern to create various types of sprite movements. Okay, so we went and talked about animating sprites last time, so let's look at what they have to say about it today. So this pattern is one of the most important in all of programming. X equals X plus 1. It is used to increase the value of a variable by 1. You might call it the counter pattern, since it can be used to make a variable that counts up. You'll use this pattern a lot, especially with the draw loop. Let's see what that looks like. So this program creates a variable, counter, and then uses the counter pattern to make it count up. When you run the program, what do you think you'll see on the screen? So you're going to read the program, make a prediction of what the output will be, run the program to check your prediction, and then discuss with the neighbor. Can you explain what you observed? Okay, so on here, I want everybody to look at these 8 lines of code and make a prediction as to what you think is going to happen. So those of you watching the YouTube later, we're going to pause this for a minute and make a prediction, and then we'll come back. All right, so we have a few predictions made. We're going to check out what actually this program is going to do here. My prediction, as it says, you're going to see a number that's going to appear at 0 and 400. So that is up here in this, we go to show grid. 0 and 400 is going to be down here. So it's going to be the lower left. So a number in the lower left will increase in size and value as the program continues to be run. Okay, so you're not going to see anything until probably 10 at least. because it's going to be really, really small. And then it's just going to keep getting bigger and bigger and bigger as the program runs. Okay, so let's check it out. So, and we had a prediction of whether or not it's going to stop at 400. I don't think it's going to stop. So there's 4, 20, 40, 50, 60, 70, 80, 90, 500. So we could just have this keep running. Granted, it'll get so big that we can't really even tell what number it is. So we get to 8. We don't have time for it to go to 1 billion. Okay. So, can you explain what you observed? Can anyone explain to me what was happening? What do you think, Tim? Yeah, can you explain what's going on here?
I literally had it down and then I forgot.
Right here. This is what's happening. It's growing bigger. Every time it goes through the draw loop, it's executing every single one of these commands. So it's going to draw a white background. It's going to set the text size of the text size to whatever the current value of counter is. It's going to display text that's going to show a number, which is what counter is, at 0 and 400. And then after it does those things, it's going to increase counter by 1 before it goes back and repeats all of those commands again. Keeps adding 1 over and over and over and over again. Exactly. So, let's check out their little video that explains this a bit. Here we go. Counter pattern. Animate with sprites.
You can animate with sprites too. To do this, you'll need to update the properties inside the draw loop using the counter pattern. For example, this program creates a sprite called mySprite. Then, inside the draw loop, it uses the counter pattern to increase the sprite's X position by 1 in each frame. This makes the sprite move smoothly across the screen. Adding a second sprite to a program is easy. You just use the create sprite command again. This program animates 2 sprites called Sprite 1 and Sprite 2. Sprite 1 uses the counter pattern to move across the screen by adding 1 to its X property. Sprite 2 moves down by adding 1 to the Y property on each tip of the draw loop. These sprites have lots of other properties, but our program only needs to deal with the ones that are changing. Sprites already help you write more readable programs, and they're going to be extremely helpful and powerful tools for making fun games and animations. So stay tuned.
So on this, we're seeing very simple examples of just a sprite moving across the screen. Okay, and we're seeing just 2 sprites that are just kind of moving at the same pace. But imagine all the possibilities of what we can do with this ability. We can start to detect, and we can use if statements to figure out, hey, are these sprites touching? And if they do touch, then we can do certain things. We can add to the score. We can make one blow up. We can make one disappear. We can make them change position. We can do all kinds of things. So this is really a really important concept for us to be able to develop our games, to understand how exactly this is working and what's going on. So you've got the airplane and the jet that are moving here. Using the counter pattern, you can write programs that animate sprites smoothly. Adding to or removing from a sprite's X or Y property in the draw loop makes your sprite move just a bit each time it is redrawn. So read the code that makes the jet go up the screen, add code that makes the plane move to the right, as in the sample image, right? So if we look at this, the jet is moving, but my plane is not. So if I scroll down here and make this bigger so I can see more, okay, you see the jet y equals jet y minus 3. So this is where it's important for you to understand the grid. How we went over the grid before, and I said, hey, it's really necessary that you know how this works. Because if I want something to move up, then I've got to decrease my y, which is what they're doing right here. If I wanted it to go down, then I have to increase the y. So if I want this to move to the right, do I increase or decrease my x?
Increase.
Need to increase the x. Okay, if I want it to move to the left, then I would decrease the x. Okay, so move your plane over, add your code here, which is what this comment here is telling us. So we can copy and paste this if we wanted, and then change it from plane, from jet to plane and y to x, or we can just go here and we just grab this sprite.x. You're like, well, that's only sprite.x, Mr. Twining. But if you pull it over, what it's going to do is it's going to set up a sprite.x equals something. And then you can put in here this plus thing. So this is where I get really like disappointed in how nitpicky students are, because they want to say, oh, well, I need the little minus thing. So you got to go into math, and you got to draw like that block, and you drag these other blocks. Just type it in. So I just type in plane right here. So plane.x, and oh, I gotta spell it right. Okay, and then I can just type in plane.x plus 3. Okay, and then it'll make the block for me. And that saves me a whole lot of time instead of having to go here, get the plus, go and get the x, and drag it over. And it just takes forever. Just type it in and it's way quicker. So now when I reset and I run, my plane's moving across and my jet is going up. And look, they just barely miss each other. Wait a minute. What's going on? Why isn't mine going back like theirs is? Did I do it wrong, Jackson? Okay, so if I wanted mine to look exactly like theirs, I would have to create a loop. But the reason that they have a loop is so that you can see over and over, this is what it's supposed to look like. Okay, so don't feel like, oh, mine disappeared and it's not coming back. Don't worry about it. We're not worrying about that right now. All you've got to do is just get it to do the first thing where they go across and they don't hit each other. Okay, don't worry about having to loop it back. We can do that later. Mania. Oh, theirs? Well, I mean, you could increase it to 5 if you want. I just left it at 3 because that's what they had originally. Okay, so that's how you get it. You add the plane.x equals plane.x plus 3, and you're good to go, and we finish. And I think we'll do this one last one, and then I'll set you loose to figure this out on your own. All right, so moving to the left. Remember, we went to the right last time. Now we're moving to the left. If adding to a sprite's x coordinate makes it move to the right, how could you make it move to the left? Make your program animate like the image to the right. Update fly.x inside the draw loop so that in each frame, the fly is drawn a little bit further to the left. Okay, you can make your sprites move faster by adding or subtracting larger numbers. Fly in our example moves about twice as fast as the plane in the last level. Okay, so on here, here's my fly, and he's not moving. So what do I need to adjust, class? I need to adjust the X, right? So I go to sprites, gonna take my sprite X here and put it there. And then we're gonna say fly, because that's the name of my variable. It's not sprite. See, it's up here, fly dot X equals fly dot X plus or minus. Minus. They said it's moving twice as fast. So what was it moving at last time? Right, it's moving at 3 pixels per drawing. Let's do ours at 8. We're gonna make it zoom across. And then we run, and there it goes. Okay, so once again, it's gone. We don't have to worry about looping back, we'll just reset. And if we wanna see it again, then there we go. Let me see the next. I think they get a little bit harder. I wanted to get one of the practice ones for you guys because those are the difficult ones. Here comes maybe. Oh, diagonal. Okay, hold on. Let me see what else we got. Because they got this one, and then there's the motorcycle one. That's very similar. What is going on my internet? Sorry about the delay, those of you watching this. It's coming, maybe. Okay, that's a little too far. We're not at lesson 23 yet. Oh, there we go. Okay. So we're back at 12. Ugh. Okay, here we go. Sprite movement. Oh, this is the skill building. Okay. All right, we'll just do this one and then you can do the rest of them. So diagonal. How do I move diagonal? Kale? Okay, so I'm gonna do X and Y at the same time. So what is the angle that I'm moving here? What's going on? Code.org is like crashing. There we go. Okay, so okay, here we go. So if I run this, where's the code that makes the mouse go down? Okay, in here is my mouse Y, right? And are we seeing a mouse? Because I'm not seeing a mouse. Reset, run. So hey, this is a great example. If you happen to have this problem, oh look, there it goes. Okay, so mouse is going down this way. Now, how do I get it so that my mouse can go across? And Kale already mentioned this. We need it to go in the X direction, the Y direction, and the X direction if we want it to go diagonally. So on here, we just need to add a line that says X as well. So I'm gonna be smart, not lazy, but smart. I'm gonna copy this line of code and I'm gonna change it to X. X. If I want it to go the same rate, meaning I want it to go straight across at a 45-degree angle, then I'm going to use the same number for both of them. And then it's gonna go like this. Now here's the challenge. If you scroll down, it tells you the challenge. Set the sprite's rotation so that it faces the direction it's moving. What's the direction it's moving? Well, yeah, down and right. But we're talking about rotation here. What's the angle of the movement? Michelle? Not quite. If we were going across, it'd be going just on the X, but we're going across and down. So 45 degrees is what we're doing. So if we go to sprites and we do to rotation. Now, do I need to do it inside the draw loop? Not necessarily. I'll just put it up here. So we're going to say mouse dot rotation equals 45. And then when I run it, oh, crud, it's going the wrong way. Let's make it negative 45 to go the opposite way. And there we go. We're all beautiful. Okay, so that is the first 6 puzzles out of like 10 for this one. So really more than half the lesson for you. Any questions? All right, you got about half an hour. Get her done. Stop the recording.